Okay, so basically, can everyone access this file? And please don't open the one in Dropbox, but copy it to your hard drive. So I'm working off a file that's on my hard drive, and we'll be copying an updated version of it to Dropbox after class. But if you open it from Dropbox, then there will be these conflicted copies and overwriting each other's stuff. So please just work from your own copy. And I think if you copy all the source files as well, then that's in this folder, then hopefully the reference images are going to work. So there are quite a number of things that I have pasted into this file that are basically pictures or measurements for the things that I have modeled and we'll be going through today. And so basically, there are three parts to the tutorial today. So first of all, we began to look at the basic two ways to draft lines and curves. So I hope that's clear for everyone. I mean, it's very similar to 2D drafting, other 2D drafting software. So I hope that here this list of operations, I hope that you will be familiar with most of these. So I'm going to go through them, but try to spend more time on the later part of the class. So please, if you want me to explain something in more detail, then just ask a question. And then the second list of commands are the first set of operations that will be very helpful, or some of them really will be necessary for working on your assignments and just creating basic geometry from curves and creating and working with basic solids. And so we will look at a number of things. So in perspective view, you can see that I have this room modeled here with some architectural details such as door frames and trims and so on. And then I have a couple of objects that I chose to be able to show you different operations, how to create and modify geometry. And then we will be using this model towards the end of class to actually create different types of 2D drawings from our 3D model. So yes, and please take a look at how I have organized my layers in this file. So right now we are mostly dealing with curves and solids, and I guess some of the things that I have modeled in 3D are really surfaces, but for our intents and purposes today, I separated the contents of the file into curves and then three-dimensional objects. And so you will see that basically most of the objects that I will be talking about, I have a layer for them under curves and under solids as well. And the reason for that is to keep my file organized, easily be able to show and hide things. So especially in the second half, when I will be creating 2D drawings, I won't need my curves at all, unless it's curves that I'm drawing onto objects because I want them to appear in a 2D drawing. And yeah, so this is really just one way to organize things, and you might follow a totally different system. So you might have an object and then different layers, sub-layers for it, for its curves and surfaces and so on. Yes?
What's the difference between the curves and solids?
Okay, so a curve is basically a two-dimensional line, although it can be, I guess it can be drawn in 3 dimensions in space, but it doesn't, it's basically a line. whether it's a straight line segment or or a or an arch or a freeform curve, it doesn't define a surface or doesn't bound space. And so it's not always the rule, but for the most part, when we are creating 3D geometry in Rhino, we begin by drawing some curves and then manipulate those, extrude those, and there are a number of other operations, some of which we won't go into today because they are produce more complex surfaces. But basically, you begin with these, but towards or in that process, these will be basically remain your source geometry, and then you won't need them very much. Except I would say that it's worth keeping everything that you work with during modeling, because first of all, if you discover a mistake later on, then it's quite possible that that mistake comes from the base geometry. So let's say you created an extrusion, but your curve wasn't closed, so it wasn't a continuous loop, and so that extrusion is just an open surface, and you might want to just go back to your curve, close it, and then extrude it again instead of trying to fix a 3D geometry, which can be harder. As well, sometimes the curves that you were working with earlier can be useful again. So, but I think keeping them separate is good because once again, when you're creating let's say, I want to create a 2D drawing of this room, and so you can see that I have these base curves that were drawn to define these walls, and I don't want those lines to show up here in my drawing. And of course I can there are ways to select curves and hide them and so on, but it's just easier if I have a master layer for curves, and I can just turn it off, and then I can be sure that there are no curves in my view that I want to work with. And so what I was saying about curves being the basis of 3D geometry is true for the most part, but there is also so if you look at these menus, then you can see that, for example, to create surfaces, there are all kinds of operations that are asking you to take curves as a basis. But of course, there are other tools that basically allow you to create 3D geometry immediately. So one example of that would be so-called primitive solids. So if you click on the solid menu, then you can see that there are a number of things like box, sphere, cylinder, cone that I can just start clicking and create a 3D object. And so this is immediately a closed poly surface, and there are no curves involved. At the same time, I can, if I want, extract curves from this geometry later on. So it's kind of a moving between 2D and 3D geometry. And so the basic distinction is curves, surfaces, and polysurfaces. Similarly to a distinction between a line and a polyline, a polysurface is made up of multiple surfaces. So let's say this, to just go back to this example, if I click on this wall, or series of walls really, then you can see that under the properties it's called a closed polysurface. So that means that it's I could say it's a watertight three-dimensional object that's bound by a surface from every direction. So if I switch the view from ghosted to, let's say, rendered, then if you kind of move around this object, you can see that it's both the top and the bottom, and all these openings have a surface. And Rhino is for Rhino, this is one object that's defined by a series of corners and so on. And actually, let's see if I can find another example. So this is kind of the final, final model that I prepared already for making drawings. But if I go to this version of this lamp here, yeah. I'm gonna go through that. So I just want to kind of talk about these basic types of geometries first. So let's say I click on this semi-sphere, which I actually created from by making a sphere and then trimming half of it. You can see that it's an open surface. And again, if I switch to rendered view, let me just zoom to it. And hide this image, you can see that it's hollow on the bottom. So this is an open surface. And why these kind of distinctions are important, because some operations that we are gonna look at later only work with solids and closed polysurfaces and don't work with open surfaces. So let me just close the door. Okay, so going back to 2D drafting. So here you can see basically two versions of the room that turn this back on, that these two drawings contain measurements for, and you can see that my sketch was totally the wrong proportion for my own living room that I never realized. It's almost a square. So basically what I did is, in fact, the drawing on the right is the one that I ended up using for most of the 3D modeling. Is I drew the series of basically I drew these walls, and then let me just hide these guys for a second. So the way I drew that is I began by a single rectangle that I gave the dimensions that my measurements contained, and then I offset that rectangle to give that wall a thickness, and then using again the measurements that I took, I have indicated these the openings for the doors and windows in plan. And you can see that on the drawing on the right, this section of the drawing is more conventionally looking like a plan, how a plan drawing would be. So these walls are trimmed to indicate that these are door openings. And so this is it's a pretty simple thing, modeling a room with some doors and windows, but it already brings up the question of, when you know that you are going to be modeling something in 3D, how will you go about drawing it? Because if I just kind of blindly draw a two-dimensional plan drawing, how it would be rendered for a construction drawing, let's say, then that might not be the simplest way to then model it in 3D. So basically, to just jump to perspective view for a second. So, and this is kind of an in-progress example here, where you can see that basically if I just took these each of these single wall segments and extruded them, which is basically, this is a command you will be using all the time, called extrude curve. And let me turn my object snaps on. So if I extruded them this way, then there would be the problem of having something to do with the space above the doors, which of course I could actually I could go ahead and, let's say, draw a rectangle here and then extrude that to the desired distance once again, and then I can unite these geometries. So maybe someone prefers to do it that way. So once again, what I'm really hoping to achieve by showing these different tools is to to make you see what their basic logic is in terms of creating geometry, and there will always be multiple ways of accomplishing things. And definitely there are faster and slower ways of doing things, and obviously I don't see any argument for spending more time than necessary on modeling, but sometimes you realize midway that there would be a simpler way of doing things, and it's not worth starting again. So in that case, there is always ways to kind of continue and use that alternative method. So yeah, basically going back to these list of commands, so yeah, I guess from this list, let's do it this way. Based on your experience in drafting in 2D, so I hope that things like move or copy or group or ungroup, I don't really need to explain. Two really important ones that might be somewhat more important than in CAD are join and explode. So and I think I already started showing that. So if I let's say just use the line command and am just drawing a series of line segments, and I want to make them a continuous line, then I use join. And if I want to break these lines to their constituent part, then I use explode. And this is the easier part. But when these two become really important is in 3 dimensions, in fact. So let's say I create a simple solid. So I'm just gonna go and click on creating a box by corner to corner, just like that. So again, this is a closed extrusion, it is called, and if I type explode, then each of the faces are going to turn into a surface. And so let's say that I actually, from this box, I just want to make an open box. So I explode it, delete one of the faces, and then select it again and go join. And so now it is called an open polysurface. And so you can see that it's basically one, it's not a group. So I could just group these faces as well, but it behaves as a single piece of geometry. So that's join and explode. Yeah, so trim and extend are, I think, also you should be familiar with them. The only thing about trim that is worth being mindful of is that it also works in 3 dimensions. So let's say I have this this box, and I'm just going to draw a single line here, and oops. And make sure that this line actually intersects this object. And so you can see that this line is going through. And so if I wanted to use this object to trim this line, I can do that. So I can type trim, and then Rhino is asking me to select my cutting object, and so I'm gonna select this, and then basically I can click on the object I want to trim. So I trim this line with this polysurface, And it works the same way with three-dimensional objects. So let me just undo this. I'm going to extrude this curve into a surface. So you can see when they are intersecting, and and actually I'm going to scale it so it goes through the whole box. For that, I'm going to use, there are 3 different scale commands. They each work in 1, 2, or 3 dimensions. So if I use the scale 1D command, and I can do this in perspective view, basically I'm able to adjust this surface only in along one axis. And this is something that I don't think AutoCAD has this option. It only allows you to scale things in 2 dimensions or 3 dimensions if they are 3D objects. And I find that I use this command quite a bit in Rhino, besides just scaling things completely proportionately. So now I have these 2 objects, and so I can use either of them to trim the other one. So again, I can type trim, and first I'm gonna choose this one as the cutting object, and so I trimmed this box with this surface. Or if I go back and do it the other way, and have the box as the cutting object, what is going on? I can trim the inside of the surface. So if after the command I hide it, you can see that I basically created a hole. So this might take a bit of getting used to, but basically the way to think about modeling is Rhino is how to define base geometries and then extrude them, manipulate them, and really how to use different geometries and their intersections and so on to produce new geometries, instead of trying to create something really complex right away. Okay, I'm just going to, yeah, actually this can stay here. So that's trim. Rotate is also somewhat interesting because there are 2 rotate commands. So if I start typing rotate, you can see that there's rotate and rotate 3D. And by the way, I'm not sure, I think both the Windows and the Mac version of Rhino, the way the commands work is that Rhino learns which ones you use most often. So so if you, for some reason, you start using rotate 3D more than rotate, then if you don't pay attention and just start typing, which is often what I do, I just start typing the commands I know and then press enter, and then don't realize that it's actually the wrong one that I'm in. So just be mindful of that. Also, the same applies to scale 1D and 2D. So I think that probably can be adjusted in the preferences of how you like to use Rhino, but it's actually a handy thing because there are so many commands that it gives you the ones you use most often first. So again, to go into 3D view or have my multiple views activated. So let's say I want to rotate this line segment by a specific angle. So Rhino is asking me to select the center of rotation, and then either I can just say I want to rotate it 30 degrees, and then it does that. And from this you can see that the positive direction in this case is counterclockwise, and so if I undo it and repeat the command and rotate it by negative 30 degrees, then it's going to center of rotation, and then negative 30 degrees, then it rotates in the opposite direction. Likewise, I can rotate using a reference point. So and I'm just gonna turn ortho off. So I can rotate freeform, or again input a number, or I can use something else as a reference. So if for some reason I want to line it up with this corner, then I can do that. And so 2D rotation, whether you do it in one of the orthographic viewports or in perspective view, it works in 2D. So if I wanted to do the same thing, and again I'm just gonna undo this, in perspective, if I type rotate, I think I mentioned that the perspective view uses the top view's construction plane. So so I'm only able to rotate this line in that two-dimensional plane here, even though I'm in perspective. And similarly, if I wanted to, for some reason, rotate this line so that it stands up vertically, then I can go into my front view. And so this is actually pretty handy to think about this while modeling. Basically, you can start a command and move between the viewports. So let's say I want to rotate in this viewport, but because when I zoom to this object, it's pretty hard to see, or maybe I'm kind of disoriented, so I'm not even sure which end of this line is which in the top view. So I can begin the command in the top viewport by clicking on the endpoint here, and then move to my front viewport and do the rotation there. And if you pay attention to the different viewports, you basically are able to reference what's going on. And so if I look at this line now in my right viewport and just hide this, you can see that it's now vertically sort of standing up. So that's just rotating basically in 2 dimensions. But sometimes you want to actually, you are in perspective view and you want to rotate an object in 3D. And I'm just going to move to something that's actually kind of more worthwhile to look at. So yeah, let's go to this lamp. So this is, I already kind of finished off the different parts of this object, but let's say that I want to actually take all of these 3 elements and rotate them in 3D, which is something that I'm expecting this lamp to be able to do in reality as well. And so I'm just going to group them. I don't need to, but it's a little bit easier if I don't by mistake deselect one of them. And so I can go and type rotate 3D, and so now instead of asking a center of rotation, it's actually asking me to choose a rotation axis. And so let's just look at this in different viewports at the same time. So basically what I'm doing right now is drawing a line, and I'm going to use this edge of this piece of the lamp as my axis. And so that's basically the 2D axis around which the object is going to rotate. And then I can pick really any angle that I want. And this operation can be achieved with the other command, but sometimes it's more easy to see what's going on in perspective and be moving something like that. And of course you can take a totally 3-dimensional axis too. So this doesn't really make sense, but I could take this endpoint here and then this endpoint, and then rotate it like that. And again, it's a bit tricky. You need multiple viewports to really see what's going on. But so I moved along that move this piece along that axis. I think that all of these things begin to make the most sense when you are doing something on your own. You have your own purpose. But I hope that it's still helpful what I'm showing. Yeah, so mirror, offset, I think those are hopefully again clear. Yeah, one handy thing can be is a command called split. So let me just hide this extrusion here. Actually, makes more sense in this drawing. So let's say I have these lines, and I don't want to just trim these intermediary line segments because in fact I need them later. I just want to split the line, and so I can type split and select the objects I want to split, and then select my cutting objects, and then press enter, and so it has broken my line into constituent segments. And once again, similarly to the trim command, you can use split in 3D as well. So let's say, just gonna show this box again. So going back to this example, I have this line here, and so I just want to split it with this box. So I can do the same, type split and select the line as my object to split, and then select the cutting object, and so I have these 3 line segments that result. And in fact, I can do it with the surface as well. So once again, split. Oh, actually, first my surface is already trimmed, but I can use this surface to split the box. So I'll do that. So you can see that the box now is broken into these 2 pieces. And then 2 commands that again are pretty useful, although the real potential is in their 3D version, is fillet and chamfer. So if you want a rounded corner, then you can type fillet, and so this is one of the examples where there are a number of things in the bracket that's worth paying attention to. So first of all, before you select any curves, you want to make sure that you have the radius you want to fillet with, and for me it often takes a number of trials and errors to figure out, unless I actually know what radius, but 1 is probably really small because that's 1 millimeter. So let's say I'm going to put 100 millimeters, and then join basically offers you the option of creating a continuous line from the 2 curves that you are filleting, which again can be a handy thing so that you end up with less line segments, or you can have a closed curve as a result of filleting. In some situations you would have lines that may be intersecting and you want to create a rounded corner from them, so Rhino can trim that. I'll show an example of that in a second too, but let's just leave it this way, and then basically select first and second curve to fillet. And No, so that's an option. So you have to click on that to change it. So either you can press J, which is the sub, brings up the sub option for join. So if you just press J and enter, then it will flip between yes or no, or you can actually just click on these options. So you can see that if I said stream no, then join doesn't even become an option anymore. Yeah, so sometimes these options don't matter so much, but sometimes, and there can be many more of them, you have to play around with some of them to get what you want to do. But so in this example, you can see that my filleted corner is actually joined, and if I go undo it and do it again without joining, let's see. Yeah, actually in this case it still remains joined because it was already, but let me just draw two lines that are not intersect. Yeah, let me do it this way. So once again I can fillet and yeah, say join no but trim yes. So I click and it created these three line segments that are separate, which is, again, depending on what you want to do, can be desirable or not. And so I could just join it together after, or I can do the command again by having join checked, and then I'm going to end up with a single piece of geometry. And chamfer works the same way as fillet, except it creates a angular corner. So if I click chamfer, then in this case you have to, instead of giving one radius, you have to give two distances from the corner for each line you're chamfering, so those two can be different. So I can put let's say 200 and 300, and so I'm going to end up with an asymmetrical corner here. Yeah, and then the blend command, which also has a three-dimensional version, is very handy when you have curves that, and they can be straight or freeform curves, but they aren't connecting, or I mean, sometimes when I use this is I somehow have, let's say, contour lines for a site plan, and for some reason, from wherever I got the data from, the contour lines are made of segments and some small pieces are missing or something like that. And instead of you having to manually draw a line, you can actually blend them together depending on how far they are from each other. And so you can see that this third segment was created based on the curvature, the existing curvature towards the end of these curves. And so this might or might not be desirable. Just to backtrack and do it again. So you can see that there are a number of options again. Oops, let me just... Yeah, so under continuity, you can choose between different options, and let's just see. So I think it was curvature, so if I check position, then yeah, so this actually creates a straight line. And if I choose tangency, or maybe that was the default setting, the result is this one. So sometimes you have to just cycle through. Yeah, and I don't know, maybe that's pretty similar, but in some cases it might be a different outcome. So you have to cycle through options to see what's best for you. I mean, in this case, Rhino is making up geometry from estimating how kind of a best fit between existing ones. it's by no means the only right solution. So you just have to be mindful of what you're doing. And then I mean, this is just useful, and I didn't know for a while that it existed, the align command, which I actually used to make this list of words. So if I just kind of mess it up a little bit, then I can select them and type align, and I can align them to the left. And obviously there are other things that you might want to align than words in Rhino. So I could select these objects and align them to their top, and you can see that my series of lines that wasn't joined kind of falls apart, and there's no reason why I would do that, but it's worth knowing that similar to Illustrator or InDesign, you can actually align things in Rhino without having to move things to, let's say, a reference line separately. So I guess, do you guys have any questions regarding these list of commands? I guess the idea is that, or I'm hoping that you are able to create a basic 2D set of lines that you can use to then move on to 3D modeling. So I don't know if any of you have tried drafting whatever things you have decided to work on for your assignments. But do you have any questions? Or is it, instead of me drafting things from scratch, is it okay to move on to showing how to then create 3D geometry? Is that good? Okay, so as I mentioned, I mean, the simplest way to use curves to create 3D geometry is using the extrude command. And if you start typing extrude, you can see that there are a number of different type or commands in this family of extrude. So the one we will be using is extrude curve, but you can also extrude a surface, which I think for the later tutorials might be something we'll go over. And besides that distinction, you can also extrude along a specific curve. So if I just take these two lines with the intention of creating my set of walls, and I type extrude curve, and press enter, then it's going to be doing the extrusion perpendicular to my construction plane, which is for the most part what you want to do. But if for some reason, let's say this this room is actually, all the walls are slanted in one direction, then I can choose to extrude them along a specific curve, which of course first I have to draw. So I'm going to just draw a line and start here in perspective view, and then go into my front view and just draw a line like this, and I will use my snap to give it the same height as the other example there. And so if I type extrude curve along curve, then it's asking me to select a path curve near start, so that would be this one. And so now my extrusion is created along that. And again, I don't think that this would be the first thing that you would have to deal with in your assignment, but it's good to know that extrude always works perpendicular to whatever construction plane you're working with, and this is a way to tell Rhino exactly which direction you want to extrude. Actually, I'll leave this here. Just maybe hide it. And okay, so let's look at what I have created here actually. So you can see that what I have here are actually two separate open poly surfaces. And actually go back a second. The reason for that is that my basis for extrusion was two open curves, because earlier I was showing you how to split a line, and I actually split this continuous wall into these two sections. So if I wanted to create a solid immediately, then and let's say I'm gonna leave this opening empty, then I have to first join these curves together, and so I have one continuous curve. And if I type extrude curve, and so this is a pretty handy option here. So the third option, solid, right now is set to no, and if I change it to yes, then basically, as I was showing before, my extrusion, it's called a closed extrusion, and what that means is that it has a top and a bottom. And once again, if I undo that and repeat and check the solid to be no, and I'll just switch to render view for a second. Hopefully you can see that it's basically, my wall is hollow, so it doesn't have a top or a bottom. And if I already have something that has been extruded and I don't want to repeat it, maybe I don't have the curves for it or for some other reason, if I have an open extrusion and its open edges are planar, then I can use the command called cap, and it's going to basically close it for me. So now you can see that it's a closed poly surface. But basically, you don't want to be manually capping every single extrusion that you make. So I recommend that, just as a best practice, you set your solid setting to yes. So you're creating solids by default, unless you really want to just create open surfaces. And so, for creating, basic architectural elements like walls or windows, extrude is a really helpful command. And so, on this, just going to hide this. So on this model here, that's kind of an in progress state of drawing the room, I'm going to show, and let's just, I'm just going to hide the trim and what is this guy? Oh, that's actually on the wrong layer. So I'm going to show how I can use the extrude command to make these other openings. And you can see that I already have the door frames drawn here, which the way I drew them was actually in the plan view, and that's something that I have hidden before. So what I just did, I clicked on show selected objects here under the sub options of the hide and show tab, and so right now Rhino is showing me all the things I have hidden in my model, and I can select whichever I want to show and then press enter, so they came back to view. So what I did is, when I was drafting, after marking where the openings are located, I created these rectangles and I rotated them up to an upward direction. So for this one, I could I could reuse the rotate command, let's say in my front view. So I could type rotate and then grab the end of this line and turn my ortho on to make sure it's completely vertical, and then stand it up like that. Or if I just wanted to do it in perspective quickly, then I can go rotate 3D. Oops. Rotate 3D and make sure I define the axis precisely, and then do that. And I can do that with each of. Okay, so here we are. Oops. Yeah, so this has reset itself. I like to be seeing my layers and properties menu at the same time, so I don't need to be switching between them. So you can drag these toolbars as you wish. So basically I have these openings here flipped up, and so what I'm going to do is to so there are actually two things I could do. One is to which in this case might be simpler, although let's see, because I have this joined polysurface, but there's a command called make hole where I can use a set of curves, and yeah, so I just clicked on this polysurface, and it's allowing me to drag this frame to basically indicate whether I want to pass through the entire thing, in which case it would make a hole in both sides, or if I do it again, I can just do it on one side. So so in the case of having this geometry already drawn, that this can be the easiest way. And the make hole command also has a counterpart where you can actually delete a hole by selecting an edge. Although, yeah, so that's not going to work when I already have this in 3D. If I just had a kind of hollow a 2D surface, yeah, let's hide this guy. So if I wanted to delete this hole here, then I think I can do that. Yes. So this can be a handy command for that. But I also want to show you how to work with extrude, and then we are actually gonna get into what are called Boolean operations, which if you don't know yet what they are, you are gonna, well, love and hate them probably. So for this, with this other door, what I'm going to do is select this object and also go into my activate my walls layer. So my extrusion is being placed on the correct layer, and I'm going to extrude this curve. And right now I'm actually not. I could precisely line it up to match this corner. Oops, and that was not quite what I wanted. In which case, if we look at it in plan view, you can see that this extrusion is exactly the width of the wall, which is fine, but right now not necessary for what I want to do. So and in fact, I would say that for using so-called Boolean operations, it's actually safer to have geometry overlap each other and kind of go beyond. So in fact, what would be even nicer if this curve was a bit further from my wall. So when I extrude it, it really, I can be 100% sure that it's, you know, like not, it was sitting on the surface of the wall, but if it's inside it a little bit, then what I want to do wouldn't work. So, oh yeah, and so my extrude didn't make a solid, so I'm just going to cap this object. And so here I have a closed polysurface, that's the wall, and another closed polysurface that's this outline of the door. And so what I'm going to do is type boolean to objects, and I guess if you guys took GIS, are you familiar with boolean operations in GIS? Or maybe that wasn't something you discussed, but basically boolean operations in both 2D and 3D. So an example of boolean operations would be in Illustrator. There's the tool set called Pathfinder, when you can kind of trim shapes with each other or choose their intersection. So if you type boolean to objects, then it asks you to select two objects, and this really only works with two objects. So if you have multiple things, you have to do them kind of one by one as pairs. And so I selected two objects, and immediately it kind of slightly changed their tone. I think they went a bit more transparent, and it's telling me to click through to iterate through results. And what's nice about this command is that basically by clicking, Rhino is showing me all the different options that logically can be the result of having these two solids interact. So in this case, it's keeping everything from this box except where it's intersecting. In this case, I think it's creating a unified solid from the two of them. In this case, yeah, this might be, the previous one might be, I think they are different in terms of what's going on with the intersection. It's a bit hard to see. Yeah, so here you can see that everything remains except their intersection. Oops, and I clicked by mistake. So if I go back and do it again, really the one I want is this one, when it's keeping my set of walls and just deleting the intersection, and also getting rid of everything about that box. So once you found the one you want, you just press enter, and then there we go. And so I mean, this is a pretty simple operation that I was showing. You can make a hole using another command, but let's say I have other kinds of solids, and so again I'm just going to draw a few very simple objects here. So I'm just gonna draw a quick box and a cylinder, and I'm on purpose drawing these so they intersect. And what else? And so, I mean, this is again totally random, but if you have any kind of solids that you want to use either to merge together to form a single solid, let's say I want to later on in Rhino to 3D print this, then submitting this geometry to the 3D printer it's not gonna be able to interpret it, because the space where these two objects intersect belong to both of them, and it just doesn't know what to do with it. So I have to have a singular geometry. So you would use Boolean operations for that. So again, it only works with two objects, and if you start typing Boolean, then you can see that all the different options that you can cycle through if you choose Boolean to objects are also available as separate commands. So if I just want to merge these two objects, I can simply choose Boolean union. And so this is a little bit difficult to see, but and I'll hide this guy for a second. But what you see here, and I'll switch to X-ray. I don't know which one is easier. It's basically the result is a singular object that's one hollow space inside, and these are all the faces of it. And so then I can take these two objects and do the same thing. Boolean union. And so now this is a single piece. But I can, instead of uniting them, I can also, I just find the Boolean two objects useful because you can just kind of cycle through, and so let's say I want to use this pyramid to delete a piece, and so that's my resultant geometry. And kind of jumping ahead a bit to this example of the lamp again. So you can see, I mean, this is it's just a lamp from IKEA that I have at home, and if I turn back on the raster reference, you can see I just very crudely modeled it using these two images. I think what I did, I measured the base diameter and then kind of just eyeballed the rest of the proportions because I wasn't worried about getting it exactly perfect. And that's actually a good piece of advice for whatever you're modeling for assignment. The goal of the assignment isn't to prove to me that you can model something exactly how it is in reality, but to model something with a purpose in mind. And so an example of that is that this lamp, of course, operates with a series of hinges, so it can be adjusted, and I kind of modeled this lower one, but at this junction I just repeated these box-like extrusions, and you can see that in 3D they intersect, and that's going to become a problem later on when we want to make a 2D drawing of this. So what I can do is, disregarding the fact that these are moving parts, to Boolean these objects together. And so the Boolean union command, unlike Boolean two objects, it can be applied to as many objects as you want, with the only exception that things that cannot be, so Boolean only works on closed polysurfaces. So anything that is in this model, I actually have an open curve, that's this spiral here, and I have an open, I think I grouped this earlier. So I have an open surface and an open polysurface, and so various things. So if I select the whole thing and type Boolean union, basically you can see that it actually highlighted all these curves that I had selected in this operation that it definitely couldn't deal with. And why it's nice that they are selected, because I could, if for some reason they were on the same layer, I could just delete them or hide them or move them to a different layer. Right now I'm just gonna turn my curves layer off, and so you can see that basically everything that could be joined together by this operation has been joined, and including, in fact, this open polysurface. And I think the reason for that is that it actually was created from a solid. So sometimes it actually matters what's the basis of geometry. If this was just a flat surface, then I don't think it would have would have worked to boolean this together. But what's nice now is, and this kind of relates to creating 2D drawings, but after you joined objects together with the Boolean operation, you can see that the original geometry of this corner kind of intersecting in space with that is still visible. And so I'm just going to, this is a bit jumping ahead, but I'm just going to do a test of rendering this into a 2D drawing, and I go through this command in more detail, but I just want to check something. Yeah, so actually in this case it already, so you can see that so this is just a set of 2D lines that have taken that view, and clearly there's some mess going on with how this spiral ends up intersecting these solids, but overall it's not bad. And so you can see that this corner is appears as a singular surface. So what I wanted to say, and I guess this just didn't turn out to be a good example, is that sometimes following a Boolean operation there is an extra step that's necessary to take to get rid of extra lines, and that is called merge all faces. There's also merge all edges, but basically merge all faces would simplify any surfaces that are planar and are sitting next to each other. I guess hopefully in the going through the other examples something comes up where I can show that, but it's definitely worth knowing as an operation that can save you a lot of time cleaning up a drawing. So going back to our room, here and I'm just gonna save again. So obviously, I've been working here with orthogonal geometry, but obviously you can extrude freeform curves the same way you would extrude straight line segments. So if I just draw something totally freeform and I close it and type extrude, it creates the same kind of extrusion. And I guess one thing I didn't mention about how I was creating these walls is that of course I could just extrude this wall first and then decide to give it a thickness. So I could go and type offset surface, and let's say I want it to be 20 centimeters thick, and so I would end up with this solid that's created from a surface. But if I wanted to go back to my curve, I can actually offset this curve, and once again I'll type 200 and then extrude these curves together. And the nice thing about this is that and yeah, so as long as you have the solid option checked yes, then it's going to create a solid from these two curves. So that's a really handy thing. If for some reason your geometry was more complex and it wasn't possible to to do this, then you could, like, let's say for some reason you end up with two. Let's just need my
Where's the extrude solid?
hmm?
Where's the
Extrude surface.
Oh, but where's the solid option?
You cannot extrude a solid.
Oh, you said
Extrude.
the solid option. But
Oh,
where's the-
so if you type extrude curve, then it's going to be one of the options listed to you. So if you just select the curve and then try, or just type extrude curve and select the curve, then you can see it's the third option in the bracket.
Oh, I'm not getting it. Oh.
Yeah. Okay, so here I have, and again, this is a bit tricky to see, especially because there are so many lines displaying this geometry. But what I have here is, what I want to have here is two extrusions. Is that what I've got? Yeah. And so you can see, once again, when I select something, it's described that I have two extrusions selected. And so for some reason I have this geometry and I want to create a wall from them. So I can, again, take the boolean to objects command and cycle through until I get my desired shape. So again, a number of ways to get to the same thing, basically. And so, yeah, so moving on from extrude, which in a way is the one of the simplest way to create geometry. So on this list here, there are a number of other ways to create surfaces and solids. So and there are some more that we will cover in the second half of the course after the reading break, which relate to creating more complex surfaces. But for now, I would like you to become familiar with loft, revolve, and sweep. And I think I said somewhere in the assignment that I mean, it would be nice. I understand that 3D modeling is, you are facing different degrees of challenges right now with just making anything, but I think to be more comfortable with not just boxes and extrusions, but somewhat more complex geometries and curvilinear geometries, I recommend that you choose something, some object for which you have to use one of these commands. So I'm going to start with sweep just because I have something in this room that was created using that, which in fact is this door frame here. So you can see that this is it's an open poly surface. So what that means is if I hide the wall, yeah, it's a bit tricky to see, but I think that something about this object is open. I think it's probably it's not, yeah, so you can see here that it's not capped on the bottom, but basically it's closed on all four sides. And okay, let's just switch back. So the way I created this was, I mean, of course I could make it from different parts. So I could draw a curve, and I'm going to turn on my curves because there should be, yeah, so I could take this curve and extrude it to the desired height, and then do it on the other side, or maybe mirror the resultant object, and then maybe take the object, rotate it, and rotate it horizontally, so it's creating the third piece. But what I actually can do is I can take this geometry and use the sweep command, and I'm going to use the one that's called sweep1 to move it along another line. And so for that reason, I have extracted this outline of the door, and I'll do that, show you how I did that, because it's again a really handy command. So I just activated my walls layer, so this curve is going to remain with my other curves here, and I'm going to use the duplicate edge, in short form dup edge command, and so it's just telling me to select edges to duplicate, and by holding shift I can select these series of 3 lines and press enter when done. So I'm gonna press enter, and so now it extracted these 3 edges as curves, and what I'm immediately gonna do while they are selected is type join and join them together. So, and I'll hide this wall once again. In fact, I don't need it to be visible while I'm doing this. So I have this curve here, and in fact I do have the geometry from my door from before, so I could have just actually taken this, moved it over, and trimmed it. So it's again good to keep curves because you don't have to draw them again. But also it's really handy to know that when you have surfaces and polysurfaces, you can instead of drawing along their edges, you can just extract the exact geometry. So I'm going to type sweep, and there are 2 sweep commands. Right now I'm going to use the sweep1, which basically refers to the fact that I'm using only one rail. And I think that the sweep2, I can show how that works, but I don't think that we can leave that for later, because it's for creating more complex geometry. So I'm going to type sweep1, and so it's asking me to select rail, so I'm going to select this path curve, and then it's asking me to select a cross-section curve, which is this one, and press enter when done. And so it's telling me to drag the seam point to adjust, and you can see that a little arrow is appearing here, and so basically this relates to the fact that everything that is drawn in Rhino, so any closed or open curve, it's defined, so even a closed curve, it's a continuous geometry, but it has a beginning and an end point, and especially with more complex operations, whether those things line up or not makes a difference. So, I mean, right now this, I don't see anything wrong with this, so I'm not going to do anything and just press enter, and so this dialog comes up with some different options, which, oh yeah, I have to click the option and then hit preview to show it, and it looks like some of these options actually wouldn't give me anything, and the freeform option does exactly what I wanted, creates this rectangular corner, and you can see that there are a number of options that are part of this command. Once again, this is a kind of a simple example of it, so later on, depending on what you are doing, it might be worth reading about these options and becoming familiar with them more. And actually for that, I just want to very quickly point out where I would search for that. So, I mean, in fact, I could use the Rhino help, but usually what I do is I just Google the command, and the first result is going to be pointing to Rhino's own online help manual. And so basically, for each command that exists in Rhino, it has a page like this where it's going to describe in complete detail all the different sub options, what they do. So depending on what you are doing, it is really helpful to look at this. So going back to the model. So yeah, this is good, and so I'm gonna click OK, and so there is my door frame. And I mean, to show the sweep command in a kind of more abstract way, let's say I have this. I'm going to take this curve here and join it together and just move it over so you can see more clearly. And I'm going to turn the edit points on this curve and go into my front view, grab some of these points and just drag them a little bit. So basically I'm just making this curve a bit more three-dimensional. So you can somewhat see that this is a three-dimensional geometry, and it's pretty irregular. And so what I'm going to do is just draw a circle at one of the ends. And so what I want to do is create a kind of like give a thickness to this line. And actually for that I could use the pipe command, where I can, and it automatically creates a perpendicular circle at both ends. So you can see that, and I can give a different radius. Oops, and what happened? Oh, for some reason it's not working. But actually, I'll return to that later. But basically, so I have this circle here, but it could be any shape. So in the previous example I was showing a triangle, and so I'm going to rotate this in 3D so it kind of lines up with oops. Okay, let me just change my view. Yeah, so I want to rotate this circle roughly along this axis. Yeah, something like that. And so again I'm going to use the sweep command, and actually, yeah, so often it's worth just typing the command first before having anything selected, because for this command it wants the rail to be selected first and then the cross-section curve, and then press enter. And so it looks like something is wrong with this curve, and I think that's why the other command didn't work either. So let me just backtrack for 1 second. Yeah, this might be, let me just use a section of this because I think it might be the fact that I joined multiple things together here might be causing a problem. So I mean, often in your modeling, especially when you're learning, you will be encountering things that you just don't know what's going on. And in fact, I can tell you that people who have been using Rhino like are proficient in Rhino. Like I would say I'm proficient, but sometimes there are just things that aren't working. And so I would say that it can be very frustrating, but I wouldn't, don't panic, but try to figure out why what you are trying to do is not working, and often you have to adjust your geometry or find an alternative method. So let's see if this in fact is gonna happen. And actually, I think that one problem might be that this is not, the two geometries aren't touching each other. So I'm just going to, for once, use the near command and place this line on the circle so they are actually share a point. And let's see, sweep one. Yeah, so you can see that it basically swept this geometry along the curve. And once again, it can be any geometry. So for a circle, and I'll just show with this curve. For a circle, there is a kind of one-stop operation using the pipe command, which in fact allows you to adjust the diameter, so you can create a pipe that's changing in diameter. But let's say I want to sweep a triangle or some totally other freeform object, and so this command would be very useful for that. And yeah, so I guess in the examples I was using it to create this door frame, which saved me time, because instead of having to create 3 pieces and then use the Boolean command to join them together, I was just sweeping that cross section of the frame around. Yeah, and also, I mean, similarly to this example of this line, if I turn these images back on, if I wanted to add the power cord to this lamp, then I could draw a freeform curve that loosely follows this, and then use the sweep command or the pipe command to do that. So does that make sense? Any questions? Okay, so the next one would be revolve, which hopefully self-explanatory, is useful for objects that have radial symmetry. So the example of that would be this vase, or really it's more like a bowl, that I have modeled here. And so to show you the process, let's just go to the front viewport. So what I did here is I took a as straight up an elevation possible of this object. So I took a photograph and inserted it into my model space and tilted it up, so what I'm drawing is already right side up. And so what I did, what you can see here, is that I have this curve which I basically revolved into a 3D object. But to take a step back from that, and I'll just show it on the other side here, what I did is I drew a freeform curve called interpolate curve. The one I mentioned allows you to click through a series of points that you want to be on a curve. And for drawing this, I'm going to turn off actually all my snaps, because I want to just be able to click without Rhino snapping to anything, so that I can perfectly follow this shape as accurately as possible. And so I created this curve, and one thing to pay attention to is that it looks in my front view, it looks like it's drawn on this image, but in fact when I go back to perspective, that curve is nowhere to be seen, and if I zoom to it, it's basically sitting on my construction plane, which relates to my origin. So so I will have to actually bring this curve closer to where I'm modeling. And actually before doing that, and actually that's probably better to do in top view. Yeah, so here's my curve, and for that I'm going to definitely turn ortho back on, so that I don't mess up the orientation. So you can see in the front view I'm moving this from front backwards, but in my front view it doesn't change at all, because it's those coordinates are preserved. So jumping back here, what I'm going to do is offset this curve at instead of thinking about trying to figure out what the thickness is, I'm just going to type T, which is for the third option called through point, and so now I can freeform give it whatever thickness I want. And then what I'm going to do is basically for revolve, of course you can take a single surface, so I could actually, ignoring this sort of offset, I can just draw a bottom, and yeah, I don't even need to worry about the top. I could just take these two curves, so let's lock this. I can take these two curves and join them together, and maybe that's easier to see in perspective. I can type revolve, and it's asking me to select the start of revolve axis. And so I, similarly to rotate 3D, I need to define not just a point, but a three-dimensional axis for this operation. And then it's asking me a start angle, but actually there's an option called full circle. So instead of having to click twice and maybe mess it up, I can just click that, and so it created a kind of complete revolution that's right now just a single poly surface. So compared to the other example that I have here, which oops, and the two are kind of inside each other right now. So compared to this example, which is a closed poly surface, it has a thickness. Right now I just created a surface. And I mean, why that's important is because depending on how big or prominent this vase is in my drawing, I might or might not want to give it a thickness. Because if I do and then create a 2D drawing, then there will be more edges showing up, and potentially just create a bunch of lines that printed really small can not look very nice. So modeling too much sometimes leads to having to clean things up. And let me again just quickly show what I mean by just taking a view of these two objects here. Yeah, so um, you can see that the one that has a three-dimensional thickness and kind of a more uh, defined edge here has additional lines than this one. And also you can also see that there's a problem here in terms of how these lines don't intersect, and it looks kind of weird. So um, as you move towards producing ultimately 2D drawings, it's worth checking time to time what you're actually what the end result is of what you're making, because sometimes you really have to go back and adjust your geometry. So yeah, so going back here, actually gonna go back to my front view and hide this again and hide this. So if I wanted to in fact create a complete closed poly surface, I would just draw some lines. So smart track, that would allow me to join this, and it's a closed curve, and then once I've done that, I can use revolve, and this time, because I know this is vertical, I can just use this as the revolve axis, and so I created something similar to what I had modeled earlier. So yeah, once again, if you're modeling something that has a radial symmetry, then you can use revolve. But actually, I want to model this vase in a different way. It's having seen this revolve operation, it's going to be a bit counterintuitive, but basically it will be possible to draw this vase using the command that's called loft, and loft actually, yeah, let's see, maybe I'll just show something more simple first. So let's say I turn ortho off and smart track off, and yeah, so in the top view here, I'm gonna draw a series of freeform curves, and what I'm going to do is I'm going to let's see which view is easiest to do. So I'm just going to flip them upright by rotating them in 3D, and actually, so I'm gonna do that one by one. Just pretty quickly. So in perspective, you can see that there are these three curves and totally freeform. And so if I select the three of them and type loft, then so the loft command is, and this example would go into creating a very complex 2D curved surface, but this is you will be using this a lot in modeling. It's a very easy way to create a surface with a series of curves. And so in this case, I'm creating an open surface from a series of open curves. But what I want to show with this example of the vase is that let's say I don't want to trace the outline of the vase, or maybe I'm designing something where I actually have a series of circles for which I know the the radius. And so I'm gonna just go to top view and just draw a basically I'm gonna draw one circle and then use the offset command to just sort of freeform offset it into a number of different sizes. And so in each cases I'm using the through option, where I can just determine where I click instead of giving it a number, just for expediency right now. So I have these circles here, and I'm going to move them roughly to line up with this image of the vase. And yeah, so once again, it's often useful to be looking at multiple viewports at the same time, because in my front view I can't really see which curve I'm selecting, so I'm going to just move the different move the different curves to different heights. And so now I have these four curves lined up in space, and they are all concentric. And so I can use the loft command, and so you can see that these arrows show up again, and because my geometry was created from a single circle that I offset, these starting points for the circles are all lined up, and the direction of the line is also lined up. Depending on what you are lofting together, it might be that some of the arrows are pointing in the opposite direction, and the end result is going to probably be a big mess. So by clicking, you can actually adjust these points to line them up better. And so again, you can see there are a number of options, and kind of cycling through them, you can choose which one. Like there's one, this one is made of actually straight sections, so it wouldn't be a completely smooth surface. I'm just gonna go with normal, and so that's what happened. Of course, this is very simple. I could, instead of having all of these be a circle, I can turn on the control points for one of them, let's say for the base, and actually I should do that in plan view just to make sure I'm not messing up the planar geometry. I could distort this into a freeform shape if I wanted, or I could draw a rectangle and replace one of the circles with that, and then carry out the loft command on these. So here it looks like it's probably better if I bring this endpoint closer. Otherwise, there might be a kind of weird twist which is inadvertently happening between the square and the circle. But basically, this is what I gave Rhino, and this is the result that it came up with based on this geometry. And so this is taking us to the realm of these questions about, well, what exactly am I exploring geometry when doing this, or do I know exactly what I want? And especially for the second half of the course, when you will be, instead of just copying real-world objects, you will be asked to develop new geometry on your own, I would say that Rhino for sure is a very good tool to be playing around with things, and try something and then check what you came up with and maybe reference it against sketches that you made, ideas that you have. So basically using it as a generative tool to develop geometry. But the kind of pitfall, of course, is that you just create weird stuff and then what do you do with it? So this brings us back to the question of using the tools critically and being mindful of what you actually want to do. Okay, let's go back to the list. So yeah, I mean, basically, generally speaking, if more simple orthogonal geometry will be created by extruding curves and using Boolean operations, then working with loft, revolve, and sweep will allow you to work with curvilinear or to create curvilinear objects. And so one thing I want to show here is the 3D version of the fillet command, which I used on this couch. So what you see on the left here is a more boxy version of this couch I have in my living room at home, which I just checked some basic measurements from IKEA's website, and so it's modeled proportionately, but for our purposes here it doesn't even matter. So this is basically what you see here. If I just hide this image, let me save again. What you see here is this box that, or the upper part of the couch I created by curves. I think the curves should be, yeah. So what I did is I drew two rectangles and extruded both of them. What is happening? Oh. And so I moved them in, I aligned them in space, and then I extruded them and used the Boolean command to basically delete that hole where that's the space for sitting down. And then similarly I extruded the leg and mirrored it, so I have 4 of them. And so the difference between these two versions is that this one has the edges filleted to basically add more detail to this object and give it a kind of more real, convincing feeling. And so for that, you can see that there are 2 different radii that I have used. So I have just added a more subtle one for all the edges, and then where you sit down I added a more pronounced one. And so I'll just copy this and show you how I did that. And these edges also bring up an issue that we'll later have to deal with when creating 2D drawings. So it's a good example for that as well. So basically, instead of typing fillet, I'm going to type fillet edge. And so the way this works is that you select whichever edges you want to fillet. So let's say I only want to work on just the upper part of this couch. So I can just hold Shift and select these edges. Yeah, so actually when you're selecting, I could adjust my perspective and just mouse over these edges, and yeah, just make sure that you aren't grabbing anything that you don't want. And yeah, so you can see that right now it did this really subtle operation. So I'm actually gonna undo, and so there's again an order to things. So if you already select your edges, then it's not, then the number you adjust is going to be current in the next operation. So before even selecting anything, I'm going to change this to 50 and then select my edges. So you can see that now they are outlined, or each of them has a little number 50 next to them, and then again click on chain edges, and so I didn't want to adjust those options, so just keep pressing enter until it's cycling through all of them. And so now you can see that it's actually giving me a preview of what's happening. And so if I think that looks good, then I can finish it. And then if I do it again and just choose this one, and yeah, so give it a larger number, like 150. Then this is what I get. And similarly, you can use the chamfer command to chamfer an edge. So let's say I want to just take a little bit off this bottom edge here in a sharper way. So I can say, let's say 30, and select the edge, and so it created a sharper edge. And so basically fillet edge, as the command explains, works on any kind of surface edge. But one thing to be careful of, and so for that, this is a good example, the more finished couch that I modeled at home, is that and this is a bit, again, tricky to really see. Yeah, maybe just shaded. So you can see that here, where all of these edges are intersecting and they are filleted with these different radii, it looks like the geometry is a bit messed up. So it's not a totally smooth continuity, and so why that can be a problem. And I think I have, yeah, so this is I'm just going to look at this in top view. So this is a 2D representation of this couch here. And so, yeah, you can see that, and actually I'll just turn off these white lines that are kind of invisible in this, from this perspective, but are part of the 3D model. We'll go over that in a second. But basically you can see that in my resultant drawing there is this stuff going on that basically, well, depending on what I want to do with this couch, you can see as I'm zooming out, the lines become really dense, and if you imagine this being black, it's gonna create these spots in the drawing that are probably not very aesthetically pleasing, and it just looks like something inaccurately modeled in Rhino and not cleaned up. So so the two options are, one is to clean up your 3D model, or to clean up your drawing, and you will have to do one of them. And it's really a matter of expediency and preference. So for my purposes, I'm not really super concerned about those two corners. It's gonna take 5 seconds to clean up, so I'm not going to spend more time figuring out how to make this geometry work better, because I just want this sort of slightly more realistic image of this couch. But it can be a case when this kind of issue is more systematic in your model, and so then maybe I would have to rethink how I modeled it and how I arrived to these filleted edges. Maybe I should, instead of starting from a box, maybe I should start by drawing some curves and then extrude them or loft them or so on. So again, it's just important to think about where you begin, what information you have about the geometry, and what's the end goal of the work. Yeah, so I have one more object here, but I actually I think I pretty much covered the different operations of how I created it. So maybe just so that you don't have something you have no idea about what's going on, I'll just quickly go through. So this is also not quite finished in terms of the detail I could add to it, or in terms of the reference I was using, but basically to just turn on these pictures, what I did, and I'm going to hide my solids for a second so you can see that I have 3 images of this radiator in my living room that I basically took a front elevation, a side elevation, and a plan, and I brought them, all of these images, into Rhino, and just by measuring the width and the height of the object, I made this bounding box and scaled the images so they are more or less accurate. And then using my different viewports, so using my right viewport to start drawing, and I think the image must have moved over a little bit in the process, but I drew the side profile. Basically, if I go back to perspective, you can see that because this is a repetitive object, of course I chose to just model one segment and then copy it once it's modeled in 3D. So in using the side view, I traced this larger outline, and then I traced what you can see, the kind of edge where this object tapers off, and then arranged and I mirrored that to the other side, and arranged these 3 curves, and using the same command I was showing, the loft command, I lofted them into this shape. And similarly to an extrusion, this is an open polysurface that has basically planar edges that I can just close by using the cap command. And then I also drew these smaller openings, and I think what I did is I extruded them and used the Boolean operation to just cut those holes. And I think finally, to go to this example, I copied them 9 times, and then drew a circle that I extruded through these objects, and then used the Boolean union command that I was showing earlier to basically, I think besides these hexagonal pieces here, this is a single kind of unified object. So once again, if I wanted to 3D print this, I could actually submit this file to the 3D printer and it would print this radiator. And yeah, so I mean, I hope that you are beginning to see that this is something maybe intuitively looks like a more complex object, but actually just thinking about what's the easiest way to describe its geometry, and then take a few simple operations. It's actually relatively easy to model. And so one thing I would pay attention to in whatever objects you are choosing is, are there any kind of symmetries? Is there repetition? And by no means do things more than once if you don't have to. So of course the copy command should be your best friend.